Morning. So it's time again. Oops, that sound on my computer. I have some interesting bugs. Of course, it showed up some new bugs overnight. Three of them, and they're all interesting. And I intend to go ahead and continue on the bug I worked on yesterday because it bugs me, and I think I have some ideas on how to proceed with it. I'm going to printf it a lot and see what happens, or to do all those socket bugs. I'm talking about this bug, the 3436 bug. And there, I know that Daniel Gustafsson was going to take a look at this 3445, which is about cookies, apparently a regression. And another regression. I seem to have broken the curl multi-ft set function with a patch that I merged. I think I merged it yesterday, and he filed the bug immediately afterwards. So, and he bisected it to identify this commit, which I think is weird. So I'm going to dig into that as well, I think. And there's this bug for protocol information is not populated when using the curl easy get info after a transfer. You can actually sort of ask curl what protocol did it use for the previous transfer, and it should report a correct protocol, but it doesn't apparently when you're doing transfers with the file scheme URL. So all set up for some fun debugging. I'm sure I can spend 2 hours on this, so if you have any comments or questions or anything, fire it away in the chat. We can see the chat actually remains text from yesterday, but never mind. Post your questions or whatever, and let's get on. Maybe I could start with this bug 3444. It says, I'll start out with writing a test case for this. I think that is the most useful thing to do, and it uses the library. So when doing test cases for library stuff, we have a dedicated directory with libtest. We have different we build different tests using code that for each of these tools they build a little standalone tool that uses libcurl to do things, to verify that things work as they should. So we'll do a new of these. So I can just figure out a new test number not used before, in the 1500 range maybe. So I can just pick 1558 is unused. 1558. I add a test for it here. 1558. And I'll copy 1557 just to get some inspiration on how to write it, because I can't ever remember it. So we will curl info protocol for file transfers. The name is just what is displayed when we run the test, which is useful to know, especially when it fails, so we know what failed or what worked. So the command we want to run is the lib1558 command. No, the command is options, sorry. to the tool is the 1558. Server, no server. But okay, let's leave it like that for now. Curl keywords are just tags for the tests. So they can be anything. Just they allow us to select to just run tests that have a particular tag set. It's convenient sometimes. So okay, this is basically a bare minimum test that will just invoke the command called lib1558, and we will write the lib1558 tool here. 1558. Here it is. It's blank. So let's insert 1500 perhaps, just as a bare empty thing to copy stuff from. So I'm just going to let's clean everything up. I can leave some things and remove the rest. There we have a skeleton start for a test case. Doesn't do anything, but we want to do a transfer. Maybe we could, I have an idea. The test case can also create, I think it should pass on. Oh, right. Using file is always weird because of the path. I mean, not the path, but figuring out the path of where we are. There is I can use this for so what's the diff? There's a file. Ooh, file pw. Exactly, that's the one I wanted. I think that is the one we want. File pwd log data. The contents of the file transfer is completely irrelevant. I just want a working file :transfer. And I can basically never remember exactly the syntax for doing. I think it's like that. I think I do it like this to create a file for the test case. It's often good to name the files according to the test case number so that it's easier to understand afterwards. Thank you. So the idea is that this test case, it'll just create a very, very small file called log data blah 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 with this contents, and my test program is going to transfer that and just do nothing with it. I just want a working file :transfer. Cheers. 10 minutes. Next coffee break in 50 minutes. So okay, I want this lib1558 to do. I'm just going to see if I can copy another example, perhaps better to just, well, that's the URL I want, and that's the curly's perform I want. So maybe like this. URL is the one that is passed on from the test file. So, and we set that to curl. Ask it to, let's not call it curl s, let's call it curl. We want a curl handle called curl. Here's a macro to set it up, and it returns if it fails. That's all right. With its header, doesn't matter when we do a file transfer. Oh, I already set the URL. We don't want proxy tunnel. We do the perform. We clean up afterwards. No, we don't clean up immediately. We will do a curl easy get info curl, and we will ask for which protocol was used. Protocol. And we need to make sure that we build 1558 properly. We don't yet. lib1558. And I'm just copying from the others, so I don't have to remember much how I've done this before. Let's see if everything builds fine. Of course it didn't build properly because I forgot something. Well, of course there will be new protocols. I mean, there are new protocols all the time, everywhere. So for curl, there aren't that many new protocols though, because we stick to basically the application protocols that are built on top of the transfer protocols in the internet stack, and I try to limit protocols to protocols that are actually sort of transfer oriented, and they have a URI or URL specification that limits the set a bit. But of course there will be changes in protocols over time, not that it happens very fast. And I think going by the history, we see that the existing protocols change more than we actually get new protocols. So I mean, there aren't that many internet transfer related new protocols that applications are using introduced much recently. You know, the last protocol we added to curl, I can't even remember. That's actually an interesting question. Let's see if I can see. I added, well, obviously I didn't. I added support for, well, maybe it was the SSH based protocols. We added Rtmp in 2010. And Rtmp is one of those really, really rarely used protocols that I think we sometimes are better off not having, but okay. I think that's the most recently added protocol we support in curl. So yeah, it doesn't happen that often. 2010, so that's 9 years ago now. Well, soon. So yeah, I think adding things in the transport layer like TCP and the coming quick, I think that is where things might still happen. So of course, things never settle down completely. There will always be new things to do and new protocols, and we can keep busy. So obviously this macro requires something that I didn't provide. I think it requires test. Yeah, it requires a label for when it fails, like this. I think. Can't even remember my own setups. And so it links all the test files and it seems to work. Maybe, yeah, I think it already went over that. 1558 was my new one. Yes, so it builds my little tool. Does it actually perform a transfer? Let's see. And then I can run a single test case like this, 1558 curl info protocol for memory failure. So that is typically something we don't clean up. I do an easy cleanup, so it's not that. Previously freed at. Well, this is bad. Oh, 2 cleanups. That's unwise. Why do I do it like that? I could just as well. Return 0, return maybe. Unused. I'm not so sure that right. So instead I ran into a Valgrind. So what? Jesus. 34. Mm, 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 35. Conditional jump. Surely there are no bugs left in Apache. Haven't you fixed them already? Global init. Right, and you can just keep on doing what I do. Fix one bug today, and yesterday you realize it's a regression, so and you have 2 bugs to fix. That's sort of my standard behavior, at least looking at the last few days of bug fixing. So what is this? Maybe no, I wouldn't say that the delay isn't actually it isn't intentional. It's not actually 10 seconds either, and sometimes I'm a little bit slow to respond on the texts in the chat sometimes. So it's I think there's some about 3, 4, 5 seconds delay from my the streaming delay, and then there's my brain delay from actually figuring out when someone writes something and responds to it. Because I actually also try to debug this silly thing at the same time. So what do I? Oh, right. So yeah, maybe it is upwards 10 seconds at times. I don't know. I think I actually have it set on low latency options as far as I can. Maybe. Oh well. No, I think it actually there's a slight delay. It's not a big deal. It doesn't matter that much. I don't think we need that much real-time interaction anyway, so it doesn't matter if there's a 10 seconds or 5 seconds. That's not the big. Right, stupid macros makes it harder to see what it really happens, but okay, if I just do that. And all right, I don't even check res, so maybe something did happen. If res go to test cleanup, okay, things seems to work, and now we can add a little print protocol X maybe. If we run with -k, it'll save the output files, and I think there's going to be a standard out protocol 400. This is not how it was stated in the bug. What did it say? Did I do something wrong? Search Google for this, and here it is. Handler protocol long. I think I'm doing this pretty by the book. So 400 hexadecimal, that seems about right. Protocol, what's it called? Proto.file. One shifted 10 times, is that 400 hex? I think so, isn't it? eBase 400 is 1024, that 10, the bit 10. Yes, it is. BC is my calculator byte of choice when I do things like that. Every time I bring up BC. Very good thing. Okay, I cannot reproduce. So let's do it like this. It might still be a good test case, I guess. So I will make a pull request test morning with my delay. Test. So I'm going to make a branch and I'm going to add my two little test cases. Oh, it doesn't really verify it yet. I just need to... For the test case, I can also... This is a fun thing. So I can make the test case also verify that it can verify standard out, that the standard out contains the right contents. And we know that it should contain... Where is it? Blah, 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 blah. It should say... Oh, it should say hello also because it outputs the data. So let's check it. It was already built 1558. Does it work? Yes, it does. These little flags on the beginning of the line actually tells what the test verifies. Standard out, and it checks the exit code, I think, and that's the memory debug system, and that's V for Valgrind, I think. If I run it without Valgrind, the V disappears. So, kind of obscure, but still. Okay. 1558, it verifies that it actually works to get the protocol after verifies on file transfer. And then we push it to Git like this, create a new branch, and then I skip over to GitHub and just create a boom labels. Let's label it as a test. that's 3447. So I go here and an attempt to reproduce this issue, but test case seems to work. Boom. So maybe it was more complicated than so. Back to this. I worked on the a lot of red X's on the pull requests recently, and that is highly annoying. Here's my fix that I've been working on the last few days. I talked about it yesterday too. This is the xattrib bug fix that removes the credentials from the URL when doing the xattrib option on curl. And it's so annoying because everything works except for some silly build bot mingw builds, and they are highly annoying because I don't understand them. So they look like this. If I look at the build, and I can see that my particular build is that 1621 is the new it's a unit test, and it says this, so it fails to link the program that runs the test case. Very annoying, and I don't understand why the mingw build would have a problem with this in particular. And it's only for the debug build, but that's quite and the debug build is the only one that runs the unit tests. But I don't know why. Why? So it works on Solaris, it works on all the Travis builds. Very frustrating. I don't have any of those. I don't have any system like that myself. I can't build it myself and try it. I'm debugging curl. That's what I'm doing. Plain C code on Linux mostly. But at least what you're seeing here is Linux. It's okay. Back to the. I'm going to go back to this bug of yesterday because I'm very puzzled by it. Back to 3446. This is the issue I worked. I got lost in yesterday. It is a bug that it's a code that uses the libcurl event-based API, and it seems to misbehave somehow. And now I'm going to dive into why or how and if it really does. The event-based system does callbacks to the application about which sockets to wait for and what to wait for on each socket. And it seems that maybe there's some issue there. And what is interesting now, it strikes me, is that this is basically the same as the new reported bug as well. So I'm going to try my debugging without this. I'm going to rerun it without this patch and see if anything is different. I shouldn't use all cores for I better. What? I see some potential for some fixing here. Okay. Right, I have this check source warning on wrong copyright dates, but that's annoying when I just want to do some quick checks. Okay, so this builds, and I'm having this test case, can't type, still 34, 36. I'm building my tests, and it uses right, that's the URL. It uses the same one as yesterday. Boom, still behaves the same, right? Did it? 34, 36. Go up to 10 URLs again. With 10 URLs the bug is more noticeable, because then it'll spend 1 second per URL. And it does, clearly. So back to 2, and I'm going to remove the revert because the revert didn't do anything. So let's use a clean git. Okay, so git master, run my or rebuild my test case. And my test case now, I'm now going to, yesterday I bumped the default search, default sleep. If there's no sleep, it would sleep a long time. But now I'm going to do the reverse, and if there's no sleep, I'm going to sleep a very short time. So if it now waits a second, it's really, this didn't spend 10 seconds. It spent 2 seconds. One million micro, 100,000. That's 0.1 second. So obviously there's some situation where the application doesn't wait for the correct socket, so waiting shorter is a solution. Oops, no, I'm silly. Let's maybe there was no change. Only if this takes less. I bet it doesn't. No, it doesn't. So it's not. It's something in curl that waits. I suspect the expect 100 logic, but it's weird. Why would it be used for this? Curl expire is the function within curl that sets the timeout for a transfer. And it's fairly complicated system to hold timeouts because curl only when using the event-based API, curl tells the application about a single timeout, the one closest in time. But of course, curl keeps track of a number of timeouts per transfer and then all transfers. So there's really a tree of timeouts. But it seems it's not really the timeout that is the issue. It's something in curl that waits. So I'll just do some fun printf debugging, basically expire in two transfers will be enough, because now I want to see the expires logic. Expire cleared. Expire 0 milliseconds for 6, and 6 is then the particular timer for that transfer. Right, because this transfer is done here, so it shouldn't be an expire cleared. This is, oh right, this is milliseconds. So it asks the expire, says expiration in milliseconds, and this is what the callback tells the application about it. So it seems to be, this is the same in milliseconds, and then some time has elapsed. Oh no, that's another timer set for another ID, timer ID. That's what the application waits for, but it doesn't wait that long because something happens. It gets... Then there's another expire for that timer ID. Blah blah blah. And then there's a separate timer, 200 milliseconds, and 200 milliseconds is surely the happy eyeballs timer. I should mention this makes things more complicated, but there are, since there are two transfers in parallel, I just want to make sure that we see which transfer that's such, which I type so badly. So now we can see, yeah, we can see there are two transfers and it sets the expiration for both. And it sets that for the same transfer, just 1 millisecond less. And then it bumps the expire. Expire cleared. Transfer. see what to learn from that. Okay, so here we see that it clears for the that's the same. Yeah. Multi done, expire cleared for that transfer. Right, and there are no timeouts left. Because a regular transfer doesn't have any timeout at all. A regular transfer can go on forever without libcurl caring about it, and if the application doesn't set any timeout, it'll just clear the timeouts, and that's what it's doing. There are no more timeouts left for the transfer, and then it'll just go on and upload. That's what happened. That is what happening. But the question is why it waits. Something in curl is waiting. Or not. It's actually there's nothing on the socket until then. Right, because that's what this is telling. These are all loops that are doing this. It'll find there's nothing to select, nothing in the from the select, and it will call this timeout function, which has nothing to do since there's no data arriving. It really looks like a server problem, but if it is a server problem, then why does it work if I do it like that? Now here's an idea. I'm going to write a new test code that actually uses the event API more like how it is supposed to be used. I think we have some example. Yeah, we have this hyper. Event-based programming always becomes messy. libev. So what if I copy the EV hyper? This is a event-based example using the libev event library. So if I might need to update the makefile. I do. Look at that. Magic. So now it built this program, and this program is fairly complicated, but it reads URLs from a pipe. So I can just, if I can pipe 10 of those URLs, and it'll complete those within 10 seconds. I think I'll just do it like this. And now I can pipe hyper FIFO. Let's go to that directory in another tab. There's now a hyper FIFO. And I'm going to paste, I'm going to create an like this URLs file, and in that URLs file I'm going to paste the interesting URL 10 times. 2, 3, 4, 5, 6, 7, 8, 9, 10. Line 10, line 1, boom. And when I do, boom, they will run in this, no, wrong tab, this tab. Done. Okay. So how long did it take? I think I need to add some sort of timer. Somewhere. Last transfer done, kill timeout. Okay, this is when the last transfer is completed in the example code. So maybe I should just say what is the best way to do this? FIFO, there's reading. Oh, add. There's a, here it is, add handle when we add a new transfer. So this gets called whenever data is received from the FIFO. That's fine, because maybe I can do we have a global for number of current transfers? No, we don't. But I can create one. Bool started. If not started, and I can make those global too, just to make them easy to use, to compare with. So just get a timestamp when everything starts, and then when last transfer done, and then I can just call started false so that I can read run. Then I will get a timeout. No, sorry, a timestamp for after, and then we know how long it actually ran. it transfers took. So maybe I need to declare them at the top then, so that they're available everywhere. Oh, there's no bool, so let's call it an int. Started. Okie dokie. So there's a timer in this code now. Run it. And in here we copy 10 URLs. Boom. How long did it take? The transfer took right. It claims it took almost 5 seconds, but why did it take 5 seconds? Well, at least it didn't take 10 seconds, which then is in the bug report. He mentioned that H2 load test he did. Which takes 1 second. I suppose this verifies his findings. Because it's supposed to be much faster, and if we compare with the original, it's supposed to be 34, 36. Which proves that there's something wrong in the event-based system, even when using a proper event library. Challenging. Just noticed that there are actually activity in the IRC channel too that I really didn't see. Just going to check my comments over here in the other bug report, see if anyone. No, he didn't respond. It was just half an hour ago. those false positive failures are really annoying. Received sig int. I'm going to ignore that particular build failure and consider this a fine patch. Allows the test to pass by 2037. So let's merge this. Bernard M. Wiedemann. Push to master. Kadoom. And it closed automatically by the commit. And one pull request down. Here's my one. I did some mistakes that the CI found that I'm going to have to clean up. That build problem, I'm waiting for feedback on that. There's some comments outstanding on that one. Clear cookie away, and I guess this is also another annoying. No, this is another annoyance, because this is, I think, is a false positive app failure build. So I'll just rerun the incomplete one and pretend it never happened. There. Otherwise, this is going to land soon as well. It's a fine fix. It's responsive and has updated accordingly. So I'm going to go back into my bug here then. For some reason, it waits. Going to expand the. I'm going to change the test a little bit to mention this. What it's. If what, I can do like this. What to string, what to name. And I'll put the name instead. I'll just have a little. just a little conversion function to make the debug output be more readable. I think you can just leave it like that. The wrong code block ran, and that was the fine one, and this is the bad one. So rebuild, run the bad one, see what it says about the particular segmentation fault. I guess that is my new function that I can just verify that. I'm pretty sure it's because I pass in something. P what is then number 3. When it waits for both input and output. Here's I'm interested in this little part here. It says set 3. It waits, tell the application wait for input on socket file handle 3, and it doesn't get any input until down here, and it right. I think I'm getting fooled by having just 2, because when having 2 handles, it can't do the second until the first one is complete. Let's do 3 transfers. That'll be much more interesting. Really annoying. Okay, it's time for a little coffee break, and then I refresh my brain and see if I can figure out anything about this. And today I have this little coffee break screen for you to enjoy. Hang on a minute. Yeah, I hope you enjoy that selection of curl crap. And now I'm going to seek comfort in some cookies as well. That's going to be awesome, right? If I'm talking with some biscuits in my mouth. Bumping up this notch. Now, let's Wireshark this. And you know what? Okay, you're not seeing this, but I can do this. Boom. This is the Wireshark captured section there, and I think what is interesting is it's easily highlighted here. The time delta here, it is 1 second. So clearly, and if I scroll up, that's almost a second as well. So clearly, and 1 second. So there is, I don't understand how this comes, but the timing seems to be from the remote, right? This is source from the other side. This is my local 192.68.192. This is my development machine. So clearly this is this seems to suggest that the delay is caused by the server. Here's the actual post. Yeah, this is sort of a mystery. This is my IRC screen. I'm gonna hide it. Hmm. Well, hex code. This is the network data that is sent in and out. This is the request, the HTTP2 request sent. All zeros. Yeah, just checking the flow control too. Huge window updates. I wonder if it makes any difference if we make a much smaller post. That would surprise me. I just want to make sure, sort of run different things to see if I can understand it. Oh, I'm still running the Wireshark, so it'll nope. I wonder if there's a magic limit. Might be, again, I'm suspecting the expect. Curl is, well, originally I thought of the word to be client URL. or client for URLs or C URL. So it's curl is a command line tool for doing internet transfers. I don't think that is physics curl very much. Interesting. So let's binary search our way to where the cutoff is. When does it start to be slow? Well, 50k is apparently slow. $10k, is that slow? Weird. So 5k is 2 seconds. 2k is 1 second. Jesus, why does it do like this? This is C code, what you look at in the text editor. Well, C code, and then there's this huge debug output in the green window. I'm back at looking at Wireshark. So the small ones, when I run them, we can easily see that there are no slowness. Well, there's one. And when I do the larger ones, they are much more common. I'm going to stop chasing this because I can't make any sense of this, and I still suspect that it might be some issue in the server side. So maybe I'm chasing something that isn't really a bug. This example code that I'm working on here, it issues 10 parallel HTTP post requests of this size to the given URL that I actually used in the command line. It's actually this test URL, which basically just threw it away and it'll sleep a second. Right, and the question isn't why it sleeps, because it's supposed to sleep. The question is why the other transfers aren't being progressed. I'm just so confused. Super confused. No, it's not slow. The thing is that this particular, yes, it's the same connection, and they're supposed to be multiplexed, and accordingly, this should sleep each stream for 1 second. So each stream should take 1 second, but then combined, they should all just take 1 second, because each stream, they would all go in parallel, so it would be 1 second in total. But with this example, it takes basically 10 seconds total, which means that the sleeping is somehow tainting everything. But it's so that's why the bug report says it's broken multiplexing. But yeah, I'm totally perplexed by it, because it's hard to figure out. Like, why would it matter if I send a smaller post? Yeah, right. I've tried to sort of reason. There might be some, and since I don't have the server code for this, so I can't really know exactly how this works in the server end either. But in the bug report, the reporter actually posted a h2 load command line, which I think does the same thing. It sends 100k data in 10 parallel streams using one connection, and it takes basically 1 second, which then we at least think is a confirmation that it actually works as suggested. I mean, server side wise. This the server is an Nginx, but I'm not sure how relevant that is, because I don't know exactly how it implements that sleeping per stream. Nginx 1.13.7. $2K really fast, $3K also fast, $4K still fast, dang. One second slower if I do it 1000 bytes larger. I wonder if it's the number of streams. Yeah, it could be the server side. That's sort of what's so complicated here. I think actually the only sane thing for me is to make sure that I have a server-side implementation that I know. That's a good question. I think they're huge. They're basically as big as possible, I think. But I'm not sure exactly what NGHP2 what it does with them. Sorry, I'm just going to see if the number of parallel streams, if that changes things, then it certainly is a server side. Well, doesn't have to be, but I would say that it suggests that it's a server side effect. So 10 streams take 1 second. 20 streams took 7 seconds. Oh. The data frames that Carl sends. Yeah, but I think one of the most curious things about this bug is that since it has this, let me show you his example case that reproduces it. There's this if-def here. This is the problematic loop that takes a long time, and then here it has this good thing below, which is another loop, which is just using the curl multi-interface in a different way, and this runs fast and this doesn't. So it's really, it's not pure server side, it's something that we do that triggers it. And I'm just so puzzled. Oh well, I need to drop it for now because I'm going insane. I need to right, I wonder how this looks like. So now I'm running the fast version, 20 parallel streams, 100k uploads in each, 1.4 seconds. Then it looks like this. Everything is very fast. A lot of hello. I'm going to do like this. I'm going to compare Wireshark wise the fast one with the slow one. Restart current capture. Yes. Continue without saving. Boom. And then I'm going to do the fast one here. I'm going to do it with 10 parallel ones. I'm just rebuilding the example. Here's the fast one in Wireshark. Boom. It took 1.39 seconds. I'm going to just let it be a little time distance. I'm going to change my code over here to do, I'm going to alter it so that I'm running this section, then the bad section instead of the good section. Still doing 100k posts, 10 parallel streams, and I'll time them, and takes a long time. We can see that in Wireshark. Yeah, so I need to understand what the differences are, so I figured this is a start at least. Or after an hour, I figure a start is good. That's not good, right? I would need to do, I want to show sort of two analyzes next to each other. Is that possible in Wireshark? I don't think it is. So here's 60 seconds interval, so here follows the slow one. Settings. So the first, let's see. No, where is Lakenstein when we need him? He's probably in IRC channel and laughing at me for not being able to use Wireshark properly. It's a little bit annoying that it just shows everything as TCP here. Yeah, if I that's true. If I can find just if I can just find two particular packets that I'm interested in, then I guess I can just do like this and pop it up in a separate window. But I'm not sure exactly what I'm looking for. I'm trying to. I wanted to get the bigger picture and see if I can see a pattern of that it's different. Since if I scroll up here, I would see the first transfers, and I would see that they look different in general than the other one, because they should. Just by glancing at them. Window update. Okay, so here it comes. Window updates for all 2, 4, 6, 8, 9. At once. Scroll, 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 and there's data sent for stream ID 1, data stream ID 3, data stream ID 5. Okay, so that the number is the stream ID. Data 7 and so on. 9, 11. That looks great. So 17. 11, 17, 15, 17, 19. Right now it just puts so many of the other packets as not HTTP2, and these they just appear as TCP or TLS. I guess I could force it to be HTTP2 somehow. And then we can see that it takes, and here are the header responses for 1, 3, 5, 7, 9, 11. So here they are all completed. Great. Okay, and here's the slow one. Settings. Well, those are our settings. They should be the same. Two, 4, 6, 8, 9. Yep, so window updates for all streams, pretty much the same way, and huge windows. Right. Each stream makes a 100k post, and the response comes back after 1 second for each stream. So each stream should take 1 second. That's the idea. And since they all do them in parallel on the same connection, it should total to 1 second. But for some reason, we can, as this is quite apparent here, looking in the Wireshark here, we can see that it certainly only sends 1. I don't think the response comes back before, because I think it makes you sleep and then it sends back the response. This is at least what it looks like, because I mean this is the data, exactly what's shown on screen here. Here's the data, which is the the post, and later on the response, 998 milliseconds later. So it looks like it actually, there's a sleep after and then response. And looking at the fast one, we can look at the fast one. There should be data somewhere. Where's the fast one? Here's the data 1. And then we can see data 3 really soon. And of course data 5, and then there's a response somewhere. There's the headers 1. Basically, it takes basically 1 second for the response to the first post to come back. And it has data in it. That's the response body. Yeah, I could filter it on HTTP2, I guess. But then I might reveal my cluelessness when it comes to Wireshark. There's oh, that's not how you do it, right? It's probably something much more complicated or straightforward. I'll just skip that for now. It's clear that it doesn't send the other posts as fast as it should. And that is of course not good. And I think it is because it somehow sets the wrong expectation on the socket, because it just sets it for reading, and it should set it for read and write. For as long as we have connect or more streams to send. I'm looking at the debug output in the like this. It tells the application to wait for input and output, that's reading and writing, and it finds it writable, and then it can upload, and then curl tells it to wait for input, and that is just for reading, but then it can't. You're right, only okay. So if I do it like this, I can just apply like this magically. Thanks. Then this is only the packets identified as HP2. So so then the bug, I'm not sure. I can't really. I mean, the bug is highly visible this way, because here we can see in the good case, sort of from here to here, we can see that it sends all the requests in a rapid pace, just milliseconds between them, and then it takes a while, and then the responses come back, and basically all after 1 second. But in the bad case, we can see that it sends data, and then it gets the response, send data, get response, send response, send response, send response, which is silly when they're all on the same connection and they're all just different streams. So back to the code. There's something wrong here. It shouldn't set. There are two things that are weird. First, it removes it. It tells the application there. Yeah, exactly. It looks like it acts on just a single stream, but it should act on a single transfer when it should act on all the transfers combined. And combined, all the transfers shouldn't set the expectation to just be input, because there might not be anything to read, but we want to write when we want to send out new transfers. So I'm going to dive into the that doesn't at all explain why it works during some condition. I mean, why the good case works fine, but let's ignore that for now. Focus on the bad case. So there's this get sock function. We have a lot of get sock functions internally in curl. That's basically the function that figures out what sockets we are working with now. All sockets for all currently ongoing transfers. And then we have logic that detects what's the difference from the last time we told the application, and then we tell the application about the update. So clearly, well, not clearly, but I suspect there's an issue in this handling, and I'm going to add some more, like printf debugging here, to see what we can do. I think single socket is the Yeah, this is so this iterates over all transfers and takes care of each transfer independently, but doing transfers independently will make it wrong, right? Since there's something clearly wrong in this treatment for multiplex transfers. which of course is good to realize, but it's also fascinating that I haven't realized it before. So we have a particular hash table for the multi-handle for all sockets used, well, file descriptors used by this multi-handle. Okie dokie 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 dokie. I can never remember the syntax for doing conditional breakpoints. I said, and I think I managed to do it. Boom. Only when removed. In this case, what is for? What is for? And that is from C area. So in this case, it is a closed. But in this case, why does it remove it here? Removed from sock hash. Well, they certainly are. There are a lot of leading fives. I would say that is one of for me, I think that's the annoying part about going 64-bit. All the addresses are so annoyingly huge. They're impossible to remember, and it's really hard to separate the different addresses from each other because there are so many numbers in common. But I digress. Remove sock from hash. I think that is a bug somehow. This socket has been removed. Tell the app to remove it. But it's only removed from this particular handle, which is this particular transfer. Well, this is a 64-bit machine, so this is a 64-bit address. But I'm not sure exactly how they figure out this address in how they make it up, I mean. Remove sock from hash. I think never gets to that point. Does it get... Ooh, is that the problem? Ah, ha, ha, ha. I think I'm closer to the bug. I think it's a regression I introduced recently. But I'm not sure. Let me see. This happens because the transfer is already done, so we have already split off the connection from the transfer. So the transfer doesn't know about its connection anymore because the connection is gone. It's not related to the transfer. And of course then it doesn't have any... so I guess actually the logic here is wrong. Somehow. It shouldn't... Yes, this is certainly a clue to the problem. I think I can verify that by reverting a recent patch, but I'm not sure I want to go that way. And this is basically logic to handle Rtmp pipelining, and we've already deprecated that and stripped off the support. You can't even enable it anymore. So I don't feel a need to keep the code around for making that work. So I should make this better by I'm thinking maybe I should have a counter for how many transfers are using the same socket. And then I can just decrease it when this transfer doesn't use it anymore, and as long as it's not 0, it's being used, so it shouldn't remove it. That's basically what this check does, but it uses the connection to figure that out, and it shouldn't use the connection to figure that out, because the connection is no longer associated with the transfer, so the transfer has no connection at this point. And I think in general we should make sure to keep the transfer separate from the connection, and that's often a reason for concern and for bugs and memory corruption and all sorts of sadness. So I should just as well grab it by the horns right now and fix this to not rely on the connection. But it doesn't actually rely on the connection. It's only that if it's not there, it assumes that that it's alone. Complicated, but necessary. What is a little complicated is that each transfer can use a number of sockets and file descriptors, so it's not one per transfer, it's a number of sockets per transfer, and some of them might be shared with other transfers. So let's try the naive approach first. If there's a socket entry that we didn't have before, add it. And we add a counter to the socket hash entry struct. Too easy, because if we just find it in the hash, we don't know if we had it before. I really think we need to remember all the sockets we use for this transfer. So that if we don't use it anymore, we can all right, we do. Yes, we do. They're in the this sockets struct. So this socket struct is the sockets we had last time this was called, and that is exactly what we need. So we can realize if this is a new socket or a socket from. Yeah, we need to know if the socket was there in the previous or the present in the hash. So then it needs to check if it's new for this. Bool existing since before, true, false. And if it existed before, since before is true. This is getting a lot of new code, but I think this is going to be a good fix. Anyway, and then break out of the loop. And if it wasn't there since before, it is. If not since before, then we are a new owner of this. So then we bump up users. Like that. Okay, so if this transfer uses a socket and it wasn't used before by this transfer, I don't recognize you, but it doesn't matter too much. And if we created a new, we are the new user of it. Then we know we're the user of it. And right, if the action is the same as before, we can just but the action needs to be the combined action. So the action let's leave it like that for now. Decrease user count. Entry users. If there are no users left, then remove it. And also, if there's no entry pointer here, something is really wrong. Maybe I should just do like this. What's wrong? What's wrong? It actually built. I'm just gonna make sure that some of the more basic things also still work before I even try to see if this fixes any problems. So I have a hash table for all the sockets that the multi-handle is using. So and now I'm adding a counter on it so that it won't remove the socket from the cache as long as it's used by one transfer. So at least the basic things work. I don't even think this function might be used in the most basic cases. It's actually a net gain in code. 56 lines gone, 37 new. And yes, users, let's make it more complicated. Users is not good enough. It should be numbers of handles using this, yes, but we can also then count inputs, maybe reads, writes. This many handles want to read. This many handles want to write. Eh. It needs to remember the old action it's set for. Okay, no, I better take a little lunch break, and I'll get on with my debugging after lunch. I might switch on the stream again just because it's... I'm gonna continue debugging this. I'm gonna fix my socket hash code. I'll kick it up again in half an hour or so. Bye.